So I want to talk about my favorite number, E, which I love saying to people because it's like, what's your favorite number? E. Is your favorite food blue? And they're like, these are not matching things, but it is a number. In fact, it's represented by this, which we'll get to in a minute. Where it comes from is compound interest. If you remember, or look into the future for maybe Liz, I don't know. But P stands for the principal, the amount of money you start out with in, say, a bank account. And then you multiply it by 1 plus the rate over the number of times in a year that something that compounds.
Yeah.
This is the annual interest. And then this, you multiply the number of times it compounds in a year times the number of years. So this just takes your amount and multiplies by 1 so that you keep all your money, because unless you invest in Lehman Brothers, you keep all your money in your bank account. And you take your rate and you divide it by, say if it's divided quarterly, it's going to be your principal times 1 plus maybe 6% over quarterly, so it's quarterly, so it's over 4. And then let's say it's just 1 year, so it's going to compound 4 times. So this becomes kind of a tedious process if you're looking at a large number here, or if you're looking at a bunch of different accounts at the same time. So mathematicians, being the sneaky devils that they are, like to find approximations to things and shortcuts.
Yeah.
So they're saying, let's say it starts compounding not just like 4 times a year, but maybe every month, every week, every day, every minute, continuously.
Every second.
Every second, every quarter second, I don't know. Continuously. So that means that this n goes to infinity. The limit approaches infinity. I don't know where you're holding that, Russ, but it's kind of interesting. Anyway.
It's
So
less
if we
shaky.
make a little substitution, something a bit more useful than u equals a.
Oh.
If we say x would equal n over r, that would also mean that r over n would equal 1 of x, right? It also means that n would equal xr.
We need a tripod.
Yeah, we need a tripod. And if you put those things into this, you would have p times 1 plus 1 over x to the x r t. And this little guy will always be the same thing as x goes to infinity. So we just call it by this symbol e. What was that symbol? As Ms. Kramer calls it, this is the PERT plus equation. And so you have your principal multiplied by e to the power of the rate times the time. And it's much simpler to do, and in fact it lets you do things like find out how quickly something's going to double. If something doubles, we're not going to have to worry about this.
Yeah.
We're just going to look for the growth rate equaling 2. So we can set 2 equal to this. And does everybody here know logs? Logarithms?
It's been a while.
What is a logarithm?
So a logarithm is the opposite of an exponential.
What's an exponential?
An exponential is a number.
Is Mrs. Yankees going to be back?
Eventually.
Probably.
Cool.
If we say this is an exponential function, its inverse would be natural log of y equals x, or probably more accurately,
Log base E.
yeah, log base e. So what's saying here is that the answer to this is going to be the exponent you have to raise the base to get that number. So, because this is used so often in math, they call it natural log, and they just abbreviate it to lny, or ln whatever's in the parentheses. So anyway, these let you undo things because you can say natural log of both sides. Natural log of 2 equals natural log of e to the rt. If you're asking what power do you have to raise e to get e to the power of rt,
It's just going to be RT.
it's just going to be rt. So rate times time equals natural log of 2. And then if you divide natural log of 2 by...
Students, if you are not involved in an activity or with an adult, please vacate the building at this time and have a good weekend. Thank you.
Since natural log of 2 is about 0.69, I believe some people actually round it to 70.72 for some reason, which will become more apparent later. This becomes, if you want to find the amount of time it takes for something to double, you'll divide this by the rate, interest rate, and you'll find out how many times compounds it will take to double. And this is where, like I said, they approximated 0.72 is actually 0.69.
Why do they approximate at 0.72?
Because 7.72 is a really divisible number, so it's easy to divide 72 by lots of different numbers. Kind of like our discussion on day 60 earlier.
360.
And so if you divide 72, the whole number, by your rates, the percentage, not the 0.06 kind of stuff, but by, let's say,
Like
0.6.
if it's 6%, you divide by 0.06.
Well, if it's 6%, you'd actually divide, in
Oh,
this,
yeah,
in this
6.
here, you would divide by 0.06, but here we're going to go with the percent. So 72 divided by 6 is 12?
Yeah.
So that means that with 6% interest, it'll take about 12 years for it to double. And that's the cool thing about this trick called the Rule of 72, I believe. Now, this is a convenient thing for, say, bankers, or even for people who are study things that grow exponentially, things like population growth, bacteria, all sorts of different things. But the funny thing about E is that it keeps popping up everywhere. And it becomes a lot, that makes a lot more sense because if you look at calculus, E, the derivative of e to the x, is e to the x. And
Why is that?
I don't know.
So then what's the antiderivative?
The e
E
to
to the x plus c.
equals e to the x, yes, and Russ stole it, plus c.
Yeah.
So e to the x is its own derivative, its own antiderivative plus a constant.
What constant?
It's c. So you,
Speed
so
of
because
light?
of this, it makes it very simple to do calculus stuff because it's just, oh, it's the same thing that you started out with essentially. You have to use chain rule on it, but it's a lot easier to remember. It's the first thing I remember when I look through derivative charts. You know, e to the x is even easier than power rule. So dx, so the derivative of natural log is even more interesting
Yes.
because it equals 1 over x.
Why is that?
I don't know. Why do you keep asking me these things?
Because I'm interested.
Okay, so that
I
would
am
also,
in
that would
math
also
club.
mean that 1 over x antiderivative would equal natural log of absolute value of x.
What is the integral of natural
So
log?
the thing about this is that anytime you have a first degree, so one form of x, will they be quiet?
Raquel Thales, please come to the main office. Raquel Thales, please come to the main office.
Anytime you have
Thank you.
a x to the 1 power, it basically just becomes natural log of that something plus c. And again, you may have to do some chain rule integration by parts, but this makes a lot of things in calculus a lot easier because these things just kind of pop up and they're really simple to do.
What is the derivative of natural log of x?
Okay, so I already said that, right?
I meant the integral.
I don't know.
Oh.
Actually, no, I do though. The
do?
integral of natural log of x equals x line x minus 1.
Oh, I knew that. Why did I say that?
Yeah.
What?
I'll see if there's a mute.
You can take it off the wall. That's what Tiller does.
There's a wire in the back you cut?
The other thing is that because e is its own derivative, it has a certain property of it makes for a really easy Taylor series, which are polynomial expansions or approximations of these. So you can pretty much write any function you want in the form of a polynomial by doing these. And its are really easy because it follows a very specific pattern. Sine or cosine, they also follow patterns, but they alternate positive and negative, and they do odds and evens, and it's really weird. This one's really easy because it's just straight ones across the top. The powers increase by 1 each time, and the powers on the bottom are all
Is it
factorial.
factorial, or is it just two?
It's 2 factorial, but
Same
it's 2.
Yeah.
Just like this is 1 factorial, this is 0 factorial. Anyway, so this is, these beautiful things called Taylor series are very simple with e to the x, and that's why they're super cool. And I love e because it is beautiful in that way, but another thing I like about e is that it's kind of a bad boy. Why? Because remember last week when we said this is undefined, 1 to the power of infinity?
Is it
Everyone said
defined?
it's 1. Duh. 1 times itself 1 billion times is going to be 1. Well,
Why?
look back at this. 1 over x as x approaches infinity, that's going to come closer and closer to 0, right?
Mm-hmm.
So it's going to be 1 plus 0
Oh my.
to the infinity. And that should equal 1. But it
Why?
doesn't. It equals e, which is 2.71-ish. So that means that e, it kind of throws this wrench
Oh.
into this plan. So because
No.
this should equal e.
No.
But 1 does not equal e, 1 does not equal 2.71, so what the crap is up with this? So even though e is actually really beautiful, it's also got this kind of dark side to it, which I really like. But back to beautiful, to close.
That's beautiful.
Because of this, the way that this Taylor series works out so cleanly, it means that if you add cosine and sine in just the right way, their Taylor series, they become e to the x equals cosine x plus I sine x. These are equivalent functions. Sorry, never mind. E to the I x equals this. My bad. So, and we talked about this earlier too in imaginary numbers, because you can write imaginary numbers in polar form that is an exponent of e. Also, because of this, let's say you substitute pi into here. That becomes cosine of pi plus I sine of pi. Sine of pi is 0, so that,
Here.
don't worry about it. Cosine of pi is -1. So e to the I times pi equals -1. And how can that possibly be that this number we made up for compound interest, when raised to an imaginary number which shouldn't exist, times pi, which is this arbitrary circle constant we picked, equals -1. Of all things, it's just, it amazes me and I love it, and that's why I like e.
E to the I pi plus 1 equals 0.
Yes. That's all I got.